Alrighty, so I've just got my hands on the 2023 Methods Exam 2. From what I heard, it's really hard, so we'll see how we go with it. I will also like to say that these are just suggested solutions. This is my first time trying it, so my answers might be wrong, some of them. So if you just let me know in the comments if I've made a mistake, that'd be great. Alrighty, so let's see. The amplitude and period of that function. So the amplitude is positive 1/2. Remember, we don't include negatives in the amplitude. And then the period, it's a sine graph, and the x is here, so it's 2 pi on 3. So the answer would be E. For the parabola with equation that, where A, B, C are elements of real, the equation of the axes of symmetry. So that's just the x coordinate of the turning point, which is negative b over 2a. So negative b over 2a. So negative 2b over 2a, which is negative b on a. So that should be A. Question 3. The two functions p and q are continuous over their domains. The two domains of the sum function, p plus q, it should be the intersection of the two domains. So this one goes from negative 2 to 3, and this one goes from negative 1 to 5. So it should just be negative 1 to 3, I think. Yeah. So that's just what's included in both of them. Yeah. Consider the system of simultaneous linear equations below containing the parameter k. The values of k for which the system of equations has infinite solutions are. So we'll just use the CAS to put these all in terms of y. So I'm just going to add a calculator. And what I'll do is I'll do menu 3(1). The first equation, k times x plus 5y is equal to k plus 5, comma y. And the other one was 4x plus k plus 1 y is equal to 0, comma y. So these are my two equations, and we want it to have infinitely many solutions. So for that, we just want the two lines to be exactly the same. So what we can do is we can do a solve. We can do the simultaneous equations, menu 371, and we just have one variable but two equations. So we're solving for k. The first equation, negative k on 5, should be equal to the gradient of the second function, which is negative 4 on k plus 1. And the second one is that the y-intercept, which is negative 5, or positive, sorry, k plus 5 on 5. We want that to be equal to the y-intercept here, which is just 0. So, and that should give us k is negative 5. So they have infinitely many solutions for k is an element of negative 5. So that is answer option B. So just negative 5. Which of the following functions has a horizontal tangent at 0, 0? What you can do is just, that would be the line y is equal to 0. So you can just do tangent line, the function, comma x and comma 0. That's undefined, so that would be probably vertical. Then just change the function. That's a positive 1/3. That's x is equal to 0. Again, that's not what we want. 2/3 probably won't make a difference. Yep. 4/3, that's y is equal to 0. So it looks like it's x to 4/3. We'll just check the last answer just in case. So that's 3/4. And that's undefined. So the answer should be 4/3. So that's D. Now the next question, suppose that integral is equal to c and 7 to 10 is equal to d. Then we want 7 to 3. So if we want 7 to 3, we can write that as the integral from 7 to a certain value a, which in this case looks like 10, of f of x dx, and then plus. So it's like we're taking a detour. So we go from 7 all the way to 10. And then as long as we start from 10 and finish where we want to finish, that's all we need. So 7 to 10 they've told us is D, and 10 to 3. They told us 3 to 10, but we can use a negative to flip that down. So it should be d minus c, and that's this one here. Apologies for the rubbish scan, but that's okay. Let f of x be equal to log base e of x, where x is greater than 0 and g of x is equal to the square root of 1 minus x, and x is less than 1. The domain of the derivative of f dash. So these are both defined for their maximal domains. Actually, this is not defined for its maximal domain because this one is not included at 1. The derivative of f of g, let's just use the cas. So I'll first define f of x as log base e of x, or ln x, and I'll define g of x as the square root, define that as the square root of 1 minus x. And then we want f of g of x, and we want the derivative of that. So derivative f of g of x, that's that. And it looks like it's going to be, well, we can just look at f of x, f of g of x, and it should have the same domain as f of g of x, just not including the endpoints. So you can also just use the domain function and put that in, comma x, and that's negative infinity to positive 1, and 1 is not included. And that makes sense because also in the derivative, we can't have 1 on the denominator. So the answer should be negative infinity to 1, not included, which is this answer there. A box contains n green balls and m red balls. A ball is selected at random and its color is noted. The ball is then placed in the box. So it's with a replacement. I can't see that word, but something 8 such selections where n is equal to m. What is the probability that a green ball is selected at least once? So let's just, this is a binomial because it is a with a replacement, and we know that we have 8 selections. So let's just say the green is binomially distributed and we have 8 selections, and the probability of getting a green is n over n plus m, right? N green balls and m red balls. So that is going to be, the probability of getting a green is n over n plus m. Now, we want the probability that green is selected at least once, so that's greater than or equal to 1, so we can just do 1 minus the probability that g is equal to 0. And you can do that on the cas. I'm not sure if it will work if I just put in letters. So menu 55 A for binomial PDF, number of trials is 8. And here we have n over n plus m. And the x value we want to have is 0. Let's just see if that works. No, it doesn't. So we can just use the formula here. So we can say NCR, and we'll do 1 minus first, sorry. So 1 minus NCR, and we have n choose 0, and n is 8, so 8 choose 0. The probability of success is, so let me just put a multiplication sign. Probability of success is n over n plus m. Oops. And that's to the power of 0. We want that 0 times. And then the same thing. So 1 minus this to the power of 8. And that gives us this. 8 choose 0 is just 1. So it's just this to the power of 8. So 1 minus, and then we can probably write this as 1 minus n plus m. If you put a common denominator, that's n plus m minus m. So it's just m over n plus m. So it's 1 minus, we can just check it. We can say, is this whole thing on the cas, we can just say, is that equal to what we think would just be 1 minus, in brackets, m over n plus n to the power of 8, and it should say true, yes. So the answer is going to be C here. So that's okay. It's a little bit tricky, but that's all right. The function f is given by that, the value of a for which f is continuous and smooth. So continuous just means they join at this point, at the point which they have the same x value. And smooth means that not only do they join, but they have the same gradient on each side. So let's first of all see what tan of 2 pi over 2 is. Tan of 2 pi over 2 is the same as tan of pi. And tan of pi is equal to 0 because it's sine over cos. So it should sine ax, and x in this case is 2 pi, needs to be equal to 0, right? Now technically that could be, well, it could be multiple values, but let's just see which one here works. Well, actually, we can see if we can eliminate anything. So these all work. 1/2, that works. -1/2, negative pi on 2. I don't think that works, but we'll just see. Now we just want the derivative to be, see what the derivative is at 2 pi. So let's just do, the derivative of 10 is sec squared, and then you got to take out the 1/2. And at 2 pi, it's just sec of pi. And that sec is just 1 over cos and squared, so it's going to be 1 over -1 squared, which is just 1 times by 1/2. So we want the gradient to be 1/2. Or in other words, we want a times cos 2 pi a to be equal to 1/2. Now that means, we can just see if the CAS will work that one out. So menu 3(1), a times cos of 2 pi times a is equal to 1/2. And we're solving for a. It didn't work. Maybe if we even just approximate it and see. So it's saying a is -2.7. I must have made a mistake. Sine 2 pi cos 2 pi a. Looks about right. Maybe it is the pi over 2. Then let's see what pi over 2 is. See, it's 1 point something. Yeah, it's none of these. No, there's not. It's not 1.18. There's a fair bit of answers. No, it's none of these. So I must have made a mistake. Let me just see what tan x over 2 is. What we can, the easiest way to do this is to just sketch tan of x over 2. So that's that, and we only really want it from 4 to 2 pi, so you can just put that restriction in. So that's just here, and then we also can sketch sine ax. Make sure you put the multiplication sign, and that is from 2 pi to 8. And yeah, we can create a slider and just enter the values. So it's definitely not, well, there was no -2. Let's put -2, which is the first answer option. That's definitely not smooth, so it's not A. We'll put -pi on 2. Definitely doesn't even connect, as we said, we eliminated that. And then we've got -1/2. Okay, that looks like a reasonable option. Let's see, +1/2. Definitely not. And 2. Yeah, not. So it's -1/2. I must have just, I don't really know what mistake I've made. 10 1/2 sec squared x over 2, and then plug in 2 pi, is pi positive 1 half That's alright, doesn't matter. Yeah, that's probably the best way to do it anyway. A continuous random variable x has the following probability density function. The value of k such that the probability that x is less than k is 0.35 is equal to. So here we don't know if this 0.35 is in the first or second graph. So what you can just do is check the integral from 1 to 6 of the first one and see if that's greater than 0.35. So we'll start by doing that. That's x minus 1 on 20 dx, and just do a control enter. That's 0.625. So it's definitely in the first one, in the first graph, because that's greater than 0.325. So we can just do a solve that this integral, and instead of 6, we'll change it to k, is equal to 0.35 comma k, and that is a negative number or a positive number, and of course it has to be a positive number because it has to be greater than 1. So it looks like k is root 14 plus 1, which is b. Two functions f and g are continuous and differentiable. It is given that that and that and that and that. The gradient of the graph of the f of x times g of x at the point where x is equal to 2. So here that's just going to be f dash of negative 2 times g of 2 plus g dash of 2, negative 2, sorry, plus f of negative 2. F dash of negative 2, they told us, is 3. G of negative 2, they told us, is 8, plus g dash of negative 2 was 2. And then times, that's a times, f of negative 2 is negative 7. So that's 24 minus 14, which is positive 10. Alright. Now here we've got the maximum possible value for the mean of x, or for e of x. I predicted this question. Alright, so first of all we can solve for the value of k. So menu 3, 1, and just the sum of all of it's equal to 1. K squared plus 3k plus k, and then minus k squared minus 4k plus 1 is equal to 1 comma k. Sorry, what did I do? So that's true for all values of k. Okay, let's just find an expression for, so this is, that just means it's true for all values of k. So no matter what k is, it's going to be equal to 1. Now let's just see what e of x is. E of x is going to be, I'll just write out this is the sum. You just, for each of these values on the bottom for the probabilities, you just need to multiply by the x value. So negative 1 is the first one, times k squared. 0, so this can just go away. And then 1 times k, that can stay the same, and then 2 times this whole thing, so plus 2 times this whole thing. So that's our expected value. Now we can do a like f min and f max. So this, we want the maximum, and this is a negative parabola. So you can just do f max of this comma k, and you get negative 7 over 6. That's the k value for which you have the maximum value for the mean. You need to sub that back in here to see what the actual maximum is. And that's 73 on 12. Why is that none of the answers? Did I make a mistake? Let's see. So it would be negative 1 times k squared, 0 is gone, then 1 times k is k, and then 2 times this So that's our expected value for sure. Comma k. Oh, but k, sorry, the reason why this doesn't work is because k itself is between 0 and 1, of course, because each of these values in the probability density function, each of those values have to be between 0 and 1, or the whole thing. So what I might try and do is say, so k definitely can't be negative, so let's try when it's 0. And that's 2. And we can have k as 0. Now let's try, I don't know if we can't have k as 1 for sure. What we can do, oh well, 2 is the biggest answer out of all the answer options. So that must be the biggest one, because we can have 2. And k can be 0 because 0, 0, 0, 0, and it adds up to 1. So that's fine. Alright, Newton's method with 3 iterations. So what would the return value of the function for that is closest to? So we just basically need to do Newton's method for 3 iterations. You don't really need to understand the pseudocode, to be honest. We just need to know the starting value. So it says x0 is the initial estimate, and that's there, so 1. So let me just define on the CAS f of x to be x cubed plus 3x minus 3. And then, what happened? Oh, and then it also actually tells you the derivative. So g of x we'll just define as the derivative of f. Right? And then what we just need to do is start with 1. So this is x0. So 1, we just, what I'll do is I'll just write x minus, and this is just a formula, f of x over f dash, or g. And I'll just put in the x is equal to 1. Now the reason why I did that is because you can just keep entering that down and changing the value. So 0. So this is 1 iteration, this is 2 iterations, and then the third iteration is 0.8177. Now be very careful because it says return x0. So yeah, no, that's fine. So 0.8177 would be the third. So that's 1 iteration, 2 iterations, now 3 iterations. So 0.81773, which is that answer there. The polynomial has that equation, the number of tangents to the curve that pass through the positive x-intercept. So the positive x-intercept is the 1/3. So how many of them pass through the x-intercept? So what we can do is just do a tangent line. We have x times 3x minus 1 times x plus 3 times x plus 1, and just do it at any value. So comma x comma a. I've got a defined as a slider, sorry. I'll just do b. Okay, so that's the equation of the tangent at any point. Now we just want to do a solve and see this equation here. We want it to pass through the x-intercept, which is 1/3 0. So y is equal to 0, so this is equal to 0, and x is equal to 1/3. And you can solve for b here and see how many solutions you get. You can just do a control enter if it's too big for the CAS. So we've got 1, 2, 3 solutions. So there are 3 of these. Okay, x be a normal random variable with a mean of 100 and a standard deviation of 20. Let y be a normal random variable with a mean of 80 and a standard deviation 10. X is a normal random variable with a mean of 100, standard deviation of 20. So x is normally distributed, mean 100, standard deviation of 20, and y is normally distributed, mean of 80, standard deviation of 10. So you can see already that x should be to the right because the mean is bigger than y, and x, it says here, is the dotted line. So the dotted line should be to the right of the solid line. So this one's out of the question, and so is this one. Also, this one is out of the question because they have the same height, and if they have different standard deviations, then they can't have the same height. Now, because the standard deviation is bigger, that means it should be more spread out. So there is a bigger standard deviation, so things deviate more from the mean. So that means C can't be correct, and that means A is the answer. 16, given that the product function f time whatever is equal to that, then the rule for the function of g is, and f of x is that. So f of x is e to the x minus 1, and times by g of x is equal to e to the x minus 1. All squared. Now we can add the powers. So we want x minus 1 plus something gives me x minus 1 squared, and that's going to be the power. So that's x squared minus 2x plus 1. And then you can, so let's just say this is going to be our power. So let's just say that's y or something. Now you can subtract x minus 1. It would be x squared minus 3x, and then when you move the 1 over, plus 1, so plus 2. So this should be the power of g of x. So g of x is e to the power of x squared minus 3x plus 2. And you can factorize that to be x 2, 1, negative 2, negative 1. So x minus 2, x minus 1, which is this answer here. Alrighty, the cylinder of height that is formed by cutting whatever, the volume of the cylinder in terms of x is given by. So the volume of the cylinder is pi r squared h. Now, okay, so the perimeter, what does it say? This circumference, or the length of this, is going to be your circumference. So in other words, h is equal to 2 pi r. That's our first equation. So the volume is equal to pi r squared and then 2 pi r. Now, what else can we say? We can say that, wait, which way is it being rotated? Thin rectangular sheet of cutting. Okay. So this is going to be x minus 2h, and this is going to be just y, and that's going to be your area. It doesn't say any values here. We just need an expression for the radius in terms of x and y, and we can get that if we figure out h in terms of x. Here, they're cutting along the dashed lines, which means they cut like that, and they cut like, so they cut out the sheet, of course, and then it makes sense that they rotate it this way so that the cylinder comes and this makes the top. So actually, the length y is going to be the circumference. So y is equal to 2 pi r. That means r is equal to y over 2 pi. So v is equal to pi times y over 2 pi squared. So that's r. And then h, we just need to figure out h in terms of x or y. And h, okay, so this is just diameters. So it's going to be, so h is basically x minus 2 times the diameter, or 2 times r. So h is x minus 2 times the diameter, which is 2 times this. So 2 times 2 times y on 2 pi. And that cancels, and you've got pi times y squared over 4 pi squared times by x minus 2y on pi. And then you've got y squared and over 4 pi times by x minus 2 pi. We just need to, it looks like they've expanded that. Now we can just use the calculator to expand that for us. So menu 3 is expand. You've got y squared over 4 pi times by x minus 2y over pi, and you get that, and we can just make a common denominator. So you can do fraction tools, so menu, number, fraction tools, common denominator, just put that there, and that's the answer. So which one is that? That's pi xy squared minus 2y cubed over 4 pi squared. That's B. That's B. Alright, now consider the function f is between that where sine is a positive integer. The number of local minima to the graph is always equal to. So if we just look at, okay, so the period of this is 2 pi on A, right? In a normal sine graph, how many stationary points do we have? Minimums do we have? So we've got, this is just one period. We just have one per period, right? Now, we're going from, so we've done 2 pi on A, and if we say that we go from negative, so let's say we went from, let's imagine A is 1. So we're actually only sketching it from negative pi to pi then. So that's going to look like that and that. So we still have just one minimum from negative 1 to 1, and that's A is equal to 1. So it's either already, just by looking at A as 1, we know that it's not 2, it's because it's not always 4, and it's not always 2 times something because it can just be 1. So it's either A or A squared, because they both give us 1. Now let's just look at what happens when A is 2. So sine 2, that means the period is pi. And also we're going from negative 2 pi to 2 pi. So actually you'll see that the period decreases with when we increase A, but the width actually increases. So it's not just going to be a linear, and it should just be an A squared, and it's probably going to be A squared, but that's the only viable answer option. Find all the values of k such that the equation has 2 real solutions for x, 1 positive and 1 negative. Such that, so this is just a quadratic. It has 2 real, 1 positive, 1 negative. So the discriminant, well, let's just solve this quadratic on the CAS. Menu 3 x squared plus 4k plus 3 times by x plus 4k squared minus 9 on 4 is equal to 0, comma x. Now, we want 2 solutions. How many is this? Well, it can only be 2. So first of all, whatever's inside this bracket, this has to be 0. It has to be positive. So let's just solve menu 3(1). This has to be positive or 0, or just let's just say greater than or equal to 0, comma k, and we get k is greater than or equal to -3/4. Now let's see what happens when we sub in just maybe this solution. And actually all we now have to do is one of them can't be 0. None of them can be 0. So let's solve menu 3(1). They can't be 0 because we want one to be positive and one to be negative. So we want this to be equal to 0, or you can solve not equal to 0, but that's fine, comma k, and you get k is equal to -3/4 or 3/4. So we actually can't include this here. So it should actually be, and let's see when this one is equal to 0. So we can have everything. So first of all, it's k is greater than -3/4 now, but also we have to exclude 3/4. And let's see what happens when we want, we should have solved, this one to be greater than 0. And we've already got a -3 to 4 to 3 and 4. Let's try the other one to be negative now. So we need this one to be positive and the other one to be negative. And we get k is greater than -3/4. So that's just the intersection between the two. And that would look like the answer is D. Yeah. Last question, usually hard. Let g of x equal to sine x, where x is an element of -∞ to 5. And f of x is that. The largest interval of x values for which f of g of x and g of f of x both exist is. So that's f of g of x. That's g of f of x. Now the inside, the range of that has to be a subset equal to the domain. The range of g, so no matter what x is, this basically goes from -1 to 1. Now, can we sub that into here? 1 over √2 is 1 point something. That's 0 point something. And that means we can't put in -1. So we actually have to restrict the domain. Right? Basically, the smallest thing, so this can only be -1 on √2, not included, all the way up to infinity. So we have to restrict this domain to be -1 on √2, because that is less than bigger than -1 to 1, and the -1 on √2 is not included. So we've got that. So we can definitely eliminate this there, and we'll see what we can do next. That's the range. So now we need to see what the domain is for that. So we can only go, so remember, sine of pi on 4 gives us √2, and we want -√2, so sine of -pi on 4. So we can't include the pi on 4, the -pi on 4, right? So it looks like it's only going to be c, because that's not right and that's not right, but let's just see. And we can go all the way up to 1, and what value gives us 1? Pi on 2. But let's just see g of f of x. G of f of x is sine of a log. Now we can input anything into a log, but the domain is -∞ to 5. So this can only equal to 5. And x plus 1 over √2 can only equal e to the power of 5 minus 1 on √2. Yeah. Now, which one, I guess, if we have -1 on root 2, is that less than? So what's sine of -1 on root 2? Just approximately. It's -0.64. Actually, we just want to know what's -1 over root 2, and we want to know what's -pi on 4. Oops. So -1 on root 2 is less. So we can't have something -1 on root 2 as our domain. So it's got to be C, I think, because these are all lower than this, and we can't have anything lower than that because of this. The lower bound has to be -1 on root 2, and we can't include it. So yeah. The multiple choice was a bit long, but I think don't waste too much time on the multiple choice. They're just worth 1 mark each. They do add up, but yeah. State all the coordinates of the x-intercepts. That's quite easy. X is equal to its coordinates, so you need 0, 0 is the origin, which is that one. We've got 2, 0, and -1, 0. Coordinates of the stationary points. They have 2 marks. You might as well just write f dash x is equal to 0. X is equal to, and just solving the cas. I might define the function as well. Define that as x times x minus 2 times x plus 1, and then just solve shift minus derivative f of x is equal to 0 comma x. These are your stationary your x values, so I'll just write them down. -√7 minus 1 all over 3, and √7 plus 1 all over 3. And if you sub them into f, you'll get the y values. So the coordinates is -√7 minus 1 over 3, 2 times 7 √7 minus 10 on 27, and then you've got f of this value, and so you've got √7 plus 1 on 3 -2 7 √7 plus 10 on 27. Okay. Now the next one is find the values of x for which f of x is g of x, and that's just 1 mark. So you can just go straight on the cas and solve f of x is equal to x minus 2 comma x, right? Now they both have a domain of real, so that's fine. So these are your x values. X is equal to -√5 plus 1 all over 2, x is equal to √5 minus 1 over 2, and x is equal to 2. So they just want the x values. Write down an expression using definite integrals for the area that gives the area of the regions. X minus 2 is going to be like that. So it looks like it's going to be, we found that that 2 is the x-intercept, the intersection point, and that means it's there. Sorry, I was on the wrong page. So yeah, just written that down, and we want to find the definite integrals. So here, that's just this area, and it also goes down all the way because it has a domain of R. So the two regions are this, and we found the intersection point, so we have the bounds. So the first integral is going to be the integral from this point, which is the lowest one, which is -√5 plus 1 over 2. And the upper bound is going to be this one, which is √5 minus 1 all over 2. And the top function is f of x minus, and the bottom is g of x dx. Then plus the integral of, and now the bottom bound is √5 minus 1 over 2. The top is negative root 5 plus 1 over 2. And now g of x is on top minus f of x dx. So that's the 2 marks there. Hence find the total area. So you just need to evaluate these integrals. I'm just going to define g of x as x minus 1. No, sorry, x minus 2. Did I solve? Yeah, that's I self-defined. Now I just want to do the integral. Now we had the lower bound is this. The upper bound is this. The first one. And then the top one was f of x minus g of x dx. Then plus, and I'm just going to copy and paste. I made a mistake, sorry, when I wrote it down, but I'll fix it up. Now it's this, and it was up to 2. I wrote down the wrong number up the top, but I'll fix that when I go back to the page. So this is 3.37, they want it to 2 decimal places, so 3.37. And I also, yeah, I wrote this should have been just 2. Okay. Let h be equal to that, where h of x is equal to f of x plus k. Find all the possible values of a and b. So h of x is equal to f of x plus k. Okay, so what they're basically saying is b is definitely going to be a turning point on the x-axis. So it's either going to be this one or this one over here, right? So we need to find, did we find the stationary points? We did find the stationary points. Yeah, so we did find the stationary points, and so b can be when k is equal to, when we move that down, the f of x down, the number of the negative. So b is equal to the x value, which was negative root 7 minus 1 on 3, when we move that down, and we just need to figure out what that value of a would be in that case. So that in that case, that's when k is equal to the negative of that value. So negative 2, 7 root 7 minus 10 all over 27. And so that means f of x is equal to f of x minus that. We just need to solve for the other x-intercept, which would be a. So then f of x plus that k is equal to 0. It's going to give us, of course, this value and another value, and with that other value is a. So you can write down the negative root 7 minus 1 over 3, and then x is equal to, and we'll just solve that on the CAS. So we're solving menu 3.1, f of x, and then I'll just get that value that we got from before, which was this one. I'll just double check. Oh, no, it was this one, and just chuck a negative on the outside. Sorry, f of x minus that, not times. And what we do there is we solve it equal to 0, comma, x. And we got, so this is our value of a, because this was our x. So x is equal to 2 root 7 plus 1 on 3. Now, what that means is that you can write ab is equal to, a is the 2 root 7 plus 1 on 3, and the b is the negative root 7 minus 1 all over 3. So that's the first case. Now the other case is when we move this one all the way up. So first of all, that means b would be equal to the x value where we have the other turning point, which is root 7 plus 1 on 3, and that means f of x, so k, is equal to positive. So we actually want to move it up, so we're plussing. So k is 2 times 7 root 7 plus 10 on 27. So we're moving that one up, because that's why I got rid of this negative, because we're moving it up that much units. This is the distance down, it's negative, and so we want to add that on to f of x. Now, yeah, so if we solve f of x plus k is equal to 0, x, of course, is going to be that b value, and we want to see what the other value is. So yeah, here it's just going to be f of x plus, and then this had a plus in there, and we get, that was the first one, the 7, that's the b, the root 7 plus 1 on 3, and the other one is negative 2 root 7 minus 1 on 3. So that's there, I've written it down. That means the other one is a, b is equal to, the a is this one, negative 2 root 7 minus 1 on 3, and b, it was root 7 plus 1 on 3. Now I just want to, so that's, I'll circle those two. I just want to make sure that I haven't missed anything. There's no other turning points on the graph, yeah. So those are the only two times when we could have a turning point on the x-axis, I believe. So it's 4 marks, so it makes me think as though they want something else, but I think that's all right. Question 2. The following diagram represents an observation wheel with its center at point P. Passengers are seated at, seated in something, I can't see, which are carried around as the wheel turns. The wheel moves anti-clockwise with constant speed and completes one full rotation every 30 minutes. When a pod is at the lowest point of the wheel, point A, it is, I can't see, 15? Yeah, 15 meters, lucky. Shown that there. The wheel has a radius of 60 centimeters, so AP is 60 meters, sorry. Consider the function h of t is that which models the height above the ground a pod is originally situated. Okay, so full rotation every 30 minutes, and t is in minutes, is it? Yeah, t is in minutes. So 2 pi on b is equal to 30. That means b is equal to 2 pi on 30, which is pi on 15. Now, what it says is that, where does it start? At A, when it's at its lowest point, it's 15 meters. So the lowest point is 15 meters. And the max is going to be 15 plus the diameter, or 120. So 135. So that means 60. So we've got the amplitude is 60, and we just need to see what it's moved up. It should be the mean position. So 135 plus 15, so you can say C is equal to 135 plus 15 on 2, and that's 75. And that's because that's going to be the mean position between this point and this point. All right, so that we go up and down by 60. Find the average height of a pod on the wheel as it travels from point A to point B. So that's just the average value of the function. Yeah, so that's going to be 1 over, from point A to point B, that's just here. So that's 1/4 of a full cycle. So that 1/4 of 30. So that's when t, so we can, when t is 0, what is this? Negative 60 plus 75 is 15, yeah. So you can imagine that this is t is 0. and then this is 1/4, so 30 over 4. So 1 over 30 over 4, which is 15 on 2, minus 0, times the integral from 0 to 15 on 2 of your function, which is h of t, dt, and that's equal to, it's to 2 decimal places. Oops. Now, we've got, I'll put the fraction on the outside. Oops. 1 on 15 on 2, which is just 2 on 15. And that's from 0 to 15 on 2. And then it's just negative 60 cos pi on 15 t plus 75 dt, and that should give you 36.8. They want it's 2 decimals, so 36.80 meters. The next question, find the average rate of change on the wheel as it travels from point A to point B. Okay. So that's the 2 points is 0, 15, and the height here is just 60 plus 15, which is 75. So that's going to be 15 on 2, 75, right? So the average rate of change is just going to be 75 minus 15, which is 60, over 15 on 2, which is 60 times 2 on 15, which is 15 times 4 is 60, and that's just 8 meters per minute. Alrighty. After 15 minutes, the wheel stops moving and remains stationary for 5 minutes. After this, it continues moving at double its previous speed for another 7.5 minutes. The height above the ground of the pod was initially at point A. After 10 minutes, can be modeled by the piecewise function. State the values of k and m. So after 15 minutes, it stops moving, and 15 minutes is we can just work out h of, so k is h of 15, and just h, I haven't defined it, h of t define as negative 60 cos pi on 15 t plus 75, and h of 15, well, I could have worked that one out, but that was 135. So k is equal to 135, and then it wants the values, the value of m. So m is just 2 because you've doubled the previous part. So, and that just means you only now need to put in half of the time to output the same value as before. So m is 2. For this, that just means that these need to connect now. So h of 2 times 20, or 40, plus n is equal to the previous part, which is 135. And we'll just put that on CAS. Yeah, and you get n is equal to 5 times 6n plus 1. And sorry, you can't put n, because that's, you're saying n is equal to n. 6k plus 1, and say k is an element of integers. Now we just need to sketch this graph. So what I would recommend is, first of all, just write out the piecewise function. So define it. So let's just say g of t, x, make it x because you're going to be sketching it. Yep, 3 equations, and the first one was just h of x, right, x not t, and that was from 0 to x to 15, and The next one was just 135, and that was from 15 to 20. And then the last one was h of 2x plus n. And n, you can just write in this value. You can write in n now and just put that in at the end. Why is there a 5? 2x plus n. And then you've got 20 is less than or equal to x, which is less than or equal to 27.5. And then at the end, I'm just going to say n is equal to this. Alright, so now I'll just go onto the graphing page and sketch it. So that was g of x. And yeah, we can create a slider. And just the tip is to make the zoom the exact same as what you've been given. So menu, window zoom, window settings. They've given you from 0 to 30, so I might go negative 10 to 40. And your x, your y, they've gone up by ones. Now your y is going from 0 to 180. So I might go negative 30 to 10. And the y scale has gone up by tens. So if you do that, you'll see the graph looks like that. And you can just get your starting and finishing point. Your starting point is just going to be g of 0, which is 15, so that's halfway here. Your finishing point is going to be at 27.5. And then g of 27.5, which is 15. That doesn't look right. What happened? G, so let's put in 27.5 here. Yeah, that's about right. And it's 34. No, that's still not right. Maybe if we change the slider. Oh, so n can be 5 times, so the minimum value is 5. Okay, so let's say that, now let's try this. What the hell? What does it say here? So, when you analyze graph, I'm just going to sketch x is equal to graph entry, and relation x is equal to 27.5. Doesn't even go up to 27. That's the problem. Maybe it comes back down. Okay, so I'm sure I defined it. So if you just draw, like, this goes up to 135 and that's at 20. Sorry, at 15. So 135 is, that's 120, 130, 140, so that's about there. And at 15, that's when it starts to go straight till 20. And then it just basically, so it goes up like that, and then it just comes down but twice as fast. And it's probably finishing at 15 as well. So like that, but I'm going to make it a bit better. And that's that. Consider that function, state the value of the limit of g of x as it approaches negative infinity. Now, we don't need the cas for that. As the power goes to negative infinity, this goes to 0, so it just is 5, because that's just an exponential, and as we go down to negative infinity, it approaches 0, and then it's moved up 5. The derivative can be expressed in the form g dash x is equal to that. Find the real number k. Now be very careful here. When we differentiate e to the power of x, that's e to the power of x. But when it's some other constant to the power of x, we just have to write that as e to the power of ln 2, which is 2, all to the power of x. So this is like differentiating e to the power of x ln 2. Now that means that k is equal to ln 2 when we differentiate that. Let a be a real number. Find in terms of a the equation of the tangent at the point a g of a. So we just, okay, so what we can do is just I'll define that function f of x as 2 to the power of x plus 5, and then tangent line f of x, comma a, and that's the equation of the tangent. Sorry, just be careful. I think my a is defined as something. I'll just delete that variable. So menu 1, 3, a, and now just do that again, and that will be the equation of the tangent. So make sure you write y is equal to, and just copy that down. So y is equal to 2 to the power of a ln 2 times x minus a ln 2 minus 1 times 2 to the a, and then plus 5. So I've just written that one down. Hence or otherwise find the equation of the tangent to g that passes through the origin. So sub in 0, 0. Then you get menu 3, 1. This is equal to 0, and you can put in 0 there, and you're solving for a, and you get that didn't work for you. Oh, it's to 3 decimal places. So you can just solve this 3 decimal places. You get a is equal to 2.618, and now you can sub that into part I, and that means y is equal to, and I'm just going to do this, and a is equal to this. So we get, what's that? So I'm just going to write 4.2547, what is it, 3 decimal places, 0.255x, 4.255x, minus 2e to the power of, it passes through the origin. This is just a really small number, so of course it's just going to have 0, 0, so it's not going to have a y-intercept. So you don't need to write that. That's just because it's approximated, it gave you something very close to 0. So that's all it is. Now, here's the Newton's method question. Find the coordinates of the point of inflection for h. So point of inflection, so this is a new graph, so I'm just going to define h of x. Did I define it right? Just wanted to make sure that I did that. Yes, okay. So it's just 2 to define that as 2 to the power of x minus x squared. Now it's the point of inflection, so you just need to solve the double derivative is equal to 0. So you can just do shift minus x of h of x is equal to 0, comma x to do decimal places. And that's 2.05, 2.06. And then sub that into h of x, so h of this, that is negative 0.07. Just reading that down. Find the largest interval of x values for which h is strictly decreasing. So what you might want to do is just sketch it. So I'll get rid of this last graph. Get rid of this actually. Just sketch h of x. And it's defined for all real values. So it's increasing. I don't think it turns off that. Yeah. So it's increasing for all values except when we zoom into this part. So that would be just from here all the way down, and then after that, that's it. So we just need, what we need to do is to just find the stationary points. It's the 2 decimal places, so we can just do it right here. So you can do menu, analyze graph, maximum, and just, that's that. And then I'll move that one out of the way. And it goes all the way down until this point here. So menu, analyze graph, minimum. And that's there. So you can, it's the 2 decimal places, so 0.485, so 49 till 3.21, and we include the endpoints. So x is an element of that. Just want to double check that with the actual calculator, because this can be sometimes a little bit off. So we're solving menu 3.1, the derivative of h of x is equal to 0, comma x, and just control enter that. 0.485, which is 0.49, and 3.21. Alright, so that looks about right. Apply Newton's method with an initial estimate of x0 is 0 to find an approximate x-intercept of h. Write the estimates as that in the decimal places. Correct 2 decimal places. So this is pretty easy. All you need to do is, I'll just define g of x as the derivative of h, which I've just already conveniently written here. And then just write x minus h of x over this. And then, sorry, just plug in 0. And just do control enters all the time. So the first thing you're writing in is negative 1.443 to 3 decimal places. Then you just enter this down, enter that. The next one you're writing is negative 0.897. And then the next one you're writing is when you sub in this value, which is negative 0.773. And then it says, so that's, I've just written that there. For the function h, explain why a solution to the equation that should not be used as an initial estimate x0 in Newton's method. Now, what's the solution to that equation? Just approximately, let's see. So, is that that's the derivative of that? That's just the derivative is equal to 0. Okay, so this is just, sorry, just looking at that, that's the derivative of h of x, this is h dash x. So if you solve the derivative is equal to 0, remember your function is, your Newton's method function is x of n, f of x of n over f dash of x of n. So then your, this leaves a denominator equal to 0 in the Newton's method formula. And you can say that's undefined. Alright, so that's just because this is solving when the derivative is equal to 0. And of course you can't plug that in there. There is a positive real number n for which the function has a local minimum on the x-axis. Find this value of n. So I guess you can solve the derivative is equal to 0, and hope, I don't think the CAS is going to work that one out. Let's see. Menu 3.1, shift minus x to the power of n. N is defined as something else. Let me just delete my variable first. Menu 1.3n, and sorry, it was the derivative of n to the power of x minus x to the power of n is equal to 0, comma x, and it didn't solve for you, but it says it has a local minimum on the x-axis. So basically what we want in this equation is, so we want, I'll write down this equation, ln of n x times n to the power of x minus n times x to the power of n is equal to 0. This is the equation we are looking at to find the x value to be on the x-axis. Now, when does this ever equal to 0? So f of x is equal to 0. When does that equal to 0? That is when n to the power of x is equal to x to the power of n. Right? So you can plug basically one of these into here, and I'll probably do the x to the power of n because the CAS doesn't like n to the power of x. So you can do, instead of n to the power of x, you can write x to the power of n. And you can solve that, I think, maybe that will work. So if you do menu 3(1), solve this, but instead of n to the power of x, you can write x to the power of n, comma n. And maybe we'll do x now. Okay, so you get x is equal to n over ln n, and that's when the gradient is equal to 0. So, and x is equal to 0, or that is when it has a stationary point. And if we sub that into the equation that we had, so n to the power of x minus x to the power of n, with this, we want that to be 0. I doubt that's going to solve. Comma n. No. Let's see what this is approximately. Oops. (2.71). Isn't that e? Huh, yeah. Okay, so the answer is e. So what I would write is just x is equal to 0, or x is equal to n over ln n. And that means n is equal to e. I'm sure you'll get the mark with that. For all these exponential, if you want to guess for all these exponential questions, if just put something in the form of e, and sometimes even e, they're always kind of the answer, if you can't get an exact answer. Manufacturer produces tennis balls. The diameter of the tennis balls is a normally distributed random variable d with mean. So d is normally distributed, mean is 6.7, standard deviation is 0.1. Find the probability that d is greater than 6.8. So that's just normal distribution. So menu 552 is normal, and we want 6.7 all the way up to infinity. And the mean is 6.7, standard deviation is 0.1, and that's 0.49999, so you can just write 5000. Sorry, greater than 6.8. I was wondering why it's 0.5. Greater than 6.8. And that's 0.8413. Find the minimum diameter of tennis balls that is larger than 90% of all tennis balls produced. So find the probability that Z is... D, why am I saying Z? Probability that the diameter is less than... greater than a certain value is greater than 0.9. Wait, let me just write that down. So we want a certain value A which is the minimum, such that it is larger than 90% of all. So we want greater than a to be 0.1 or less than a to be greater than 0.9. So we want all of this to be 0.9. So, sorry, I was on the wrong screen. But basically, I just drew it out. Probability that D is less than A, we want to be A to be anything less than A to be at least 0.9. So it's the top 0.9. So you can do an inverse normal here. Menu 553. The area is 0.9, sorry. And we'll find the standard value first. Oh, no, we actually know the mean. So 6.7 and 0.1, and that gives us 6.83. It is in, what is it, millimeters, centimeters? It doesn't say, centimeters. Tennis balls are packed in and sold in cylindrical containers. A tennis ball can fit through the opening at the something of the container if its diameter is smaller than 6.95. Find the probability that a randomly selected tennis ball can fit through the opening at the top of container. Give your answer. So in cylindrical, a tennis ball can fit through the opening of if its diameter. So just you want the probability that D is less than 6.95, and they're probably going to turn this into a binomial distribution after this. So that's menu 552 again, and you want negative infinity all the way up to 6.95. Mean is 6.7, standard deviation is 0.1. That's 0.9938 is that value. In a random selection of 4 tennis balls, find the probability that at least 3 balls can fit through the opening at the top of the container. Give your answer correct to 4 decimal places. So let's just say X is binomially distributed. We have 4 trials, 4 tennis balls, and each probability, the probability that it fits is 0.9938. Now you want to find the probability that X is greater than or equal to 3, and that's equal to, if we do menu 55B this time, binomial CDF, and we have 4 trials, and the probability of success was 0.9938. The lower bound is 3 and the upper bound is 4. That's 0.9998. So I just want to make sure that that's fine. So I'm just going to, instead of putting that value, I'm going to put the full value up here. Yeah, and okay, so 0.9998. Wow. Very likely. I hope I didn't make a mistake. Well, it should be fine. A tennis ball is classed as grade A if its diameter is between 6.54 and 6.86. Otherwise, it is classed as grade B. Given that a tennis ball can fit through the opening at the top of the container, find the probability. So find the probability that D is D is between 6.54 and 6.86, given that D is less than, I think it was 6.95. So that's just the probability of this, because all of these are less than 6.95. And that's all over the probability that D is less than 6.95. Now that's equal to, if we just put that on the CAS, what you can do is you can do a fraction first before you do anything. You can do a menu 552 on the top. You want your lower bound to be 6.54 and your upper bound to be 6.86. Your mean is 6.7 and your standard deviation is 0.1. That's on the top. It's fine if you get this error just because you don't have anything on the denominator, which you're going to fill in now. And we've actually already found that. So it was, where was it? less than 6.95 is this one. So this number here. And that will give you 0.8, how many decimals? 4 decimals. 89560. 8960. The manufacturer would like to improve processes to ensure that more than 99% of all tennis balls produced are classed as grade A. Assuming that the mean diameter of the tennis ball remains the same, find the required standard deviation of the diameter. So we want the probability. So we know, let's just say y now is normally distributed. The mean was 6.7, it stayed the same, and we don't know the standard deviation now. We want the probability that y is less than 6.86 and greater than 6.54 to be greater than 0.99. Now this will be a lot easier if this is symmetrical. Now the mean is 6.7, that's 16 up, and yes, it's 16 down. So it is symmetrical. So if you just draw it out, this is 0.99 from 6.54 to 6.86. And so you can basically solve the probability that y is less than 6.54 to be you want that to be less than 1 minus 0.99 over 2, or 0.005, or something like that. That's fine. So we don't know the standard deviation, so we can't actually work this out, and so we're going to use the standard normal. So probability that z is less than a is less than 1 minus 0.99 over 2. So we need to find that value. What is that a value? Let's find it. So inverse normal, menu 553. The area is 1 minus 0.99 over 2. The mean is 0, standard deviation is 1. And so z, or a, our a value is negative 2.57. How many decimals? They want 2. So it's 576 is all right. Now that's the z value, and we know our x value we want is 6.54 minus the mean is 6.7 over the standard deviation, and you can solve for the standard deviation that way. So I'm just going to put that on the CAS menu 3.1. This is equal to 6.54 minus 6.7 over the x, I'll just set x is my standard deviation, comma x, and that means my standard deviation is 0.06. Yeah. So basically, the required standard deviation is anything bigger than 0.06, to be honest. Now, they should have specified, they should have said find the minimum standard deviation required, but they didn't. So they should accept this, but they should also accept that, to be honest, because if this is anything bigger than that, then it will still be less than, this probability will still be greater than 0.99. So technically they should accept anything bigger, so you have to say the lowest value is 0.06. An inspector takes a random sample of 32 tennis balls from the manufacturer and determines the confidence interval to be that. Find the confidence level. So here, proportion of grade A balls produced, the confidence interval. So here we don't know p hat minus z times, we just know n, and that's fine because we have two unknowns. But we know n here, which is 32. So that's equal to that, and then the p hat plus z, the upper bound, that's equal to 0.9493. Now if you solve these simultaneously, you're going to get a z value, but be careful, that's not your confidence value, that's the area. So we'll just see what that gives us first. So if you go to the CAS and do a menu 371, we're solving for P and Z. P is P hat and Z is the Z value. And you just say P minus Z times the standard, the square root of P times 1 minus P over N. And N is 32, and that's equal to 0.7382. Just copy and paste that down. Change the left hand side to a plus and change the value on the right hand side to 0.9493 and just control enter. So you've gotten that the Z value is 1.64. Now that looks like the 90% confidence interval, but we'll see how we can get 90. Basically, we need to find what is the probability that it's between negative this, and that will give you the confidence interval. So menu 552, negative 1.644 or 645, I don't really care, because it's the nearest integer, and then 1.64501, and it's 90, so 90%. So you can write down here Z is equal to 1.64, is it 645? 6444, so just 644. And then probability that negative Z is less than Z, which is less than Z. Sorry, you can write down the 1.644. Negative 1.644. 1.644 is equal to 0.900. So therefore, 90% confidence interval. Still more probability, as there always is. How many more questions? Okay, so almost finished. I hope, if the last question isn't the worst. Tennis coach uses both grade A and grade B balls. The serving speed in meters per second of grade A is continuous random variable with that probability. Find the probability that the serving speed exceeds 50 meters per second. So that's just the integral from, okay, so I'm just going to define my function f of v to be 1 on 6 pi times by sine square root of v minus 30 over 3. So that's the function, and we just want the integral. It says 50 meters per second, so from 50 all the way to 3 pi squared. Oops. Plus 30. Oops, not in the power. Of, and we don't need this, it's just f of v dv. And that gives you, it says to 4 decimals, so 0.1345. Find the exact mean serving speed for grade balls. So the mean is just the integral from 30 to whatever of v times v, f of v. And that's 3 times pi squared plus 4. They've basically asked this question in the 2021 exam, well, just looking at that. The serving speed of grade B ball is given by a continuous random variable w with the probability density. The transformation maps that if the mean serving is that, find the values of a and b. Okay, so what happened to f of that? That means we've done a dilation by a factor of a from the x-axis. That doesn't change the domain, right? So this is just going to be, we multiply the whole right hand side. So now g, you can write g of w. That's going to be, technically you should write the 0 and elsewhere, whatever. And then you've got a on 6 pi sine root v minus 30 on 30. You can technically do this part on the CAS. Just write w over b. And then what you've done is you've dilated by a factor of b from the y-axis. Now, first of all, we'll just write what that does. Whenever you see v, it's now w over b. And that actually changes the domain. We multiply each bound by b, because we dilated by b. So that means we've got 30b is less than or equal to v, which is less than or equal to b times 3 pi squared plus 30. Sorry about that. I'll just move everything. Plus 3, 30. Yeah. And then now what happens is the mean of this. So first of all, there are two equations we can solve. The integral from 30b to b times 3 pi squared plus 30 of g of w dw is equal to 1 because it's a probability density function still. Then also the mean, which is integral from 30b to b times 3 pi squared plus 30 times g of w, w times g of w dw is equal to 2 pi squared plus 8. And then you can solve these simultaneously and get values of a and b. So it's a bit long, but what you can just do to get f of v on the case, so just define g of w as a times f of w on b, or you can just keep it as v, but we'll just say w on b. And just want to check that g of w is now a, so we multiply 1 over 6 pi, a over 6 pi, sine square root of that. It looks about right. Okay, so what we just need to do is do a simultaneous equation now. Oops. Menu 371. We've got two equations, and the two variables we're solving for are a and b. Now that means the first equation is that the integral from 30b all the way up to b times 3 pi squared plus 30, and then it's just g of w dw, that's equal to 1. Then just copy and paste this integral. Whoops, if I can just get the top one. Yeah, here. Just copy and paste that down. Your bounds stay the same, and now it's w times w because this is the mean. W times w, and that's equal to 2 pi squared plus 8. And it's saying find the values of a and b. It doesn't say. It says it. I think it wants exact. So I hope the CAS works for this. Oh, nice. Okay, so that means a is 3 on 2 and b is 2 on 3. Okay. Last question. F of x is that and g of x is 1/2 times f of 2 minus x. Complete a possible sequence of transformations to map f to g. So going this way. So yeah, they've done the dilation by a factor of 1/2. Then that you've got a reflection. First, what we can do is we can, if you write this as negative, you can write this as, negative x plus 2. That will be a bit easier to look at. Now, you can just make this x plus 2 first, and then reflect. So you can just translate 2 units left, and always write down after each step what happens. So after this step, that took it to f of x plus 2, and you've also got the 1/2 on the outside, that's fine. And then you can reflect in the y-axis. And what that will do is that will be 1/2, and then you replace x with negative x. So that's f of negative x plus 2 or 2 minus x as you need. Two functions g1 and g2 are created both with the same rule as g but with distinct domains such that g1 is strictly increasing and g2 is strictly decreasing. Give the domain and range for the inverse of g1. Okay, so domain and range. So let's just look at g1. G1 is strictly increasing. Now this, let's just see. First of all, let's define g. So g of x. First f, of course. F of x, define that as e to the power of x plus e to the power of negative x. And then g of x, define that as 1/2 f of 2 minus x. Now, we want the part that's strictly increasing for G1. So, if we look at g of x, we can just see what it looks like, kind of. Get rid of the other one. And just type in g of x. Now, that's that. So, we just need a turning point. It's exact. So, let's just figure out f min. So, you can do f min of g of x, comma x, and it's at x is equal to 2, and what's g of 2? It's 1. So that means for g of x, it's strictly increasing from 2 all the way up to infinity, right? So domain x is an element of 2 to infinity, and remember we include for strictly increasing, and that means g1 is an element of 1 to infinity. So that's the range, because the y value is 1 and it goes all the way up. The inverse of g1. So this just needs to swap. So I'll just write for g1, for g1 inverse, x is an element of going to be the opposite, so 1 to infinity, and then g1 inverse is an element of 2 to infinity. Okay. Now, below is the graph of g, the inverses of g1 and g2, and the line y is equal to x. Okay, that is the intersection points between y is equal to x are labeled, and y is equal to g of x. They're labeled p and q. Find the coordinates of p and q. So what was p? P is the intersection between the line y is equal to x and y is equal to g of x. So we can find that quite easily. Just menu 3(1), x is equal to g of x, comma x, and it's the 2 decimal places. So that is p is the smaller one, so 1.27, 2 decimal places, and we need the y, and I'll just write, I won't finish it. So q is equal to 4.09. So we just need to sub these into x. Oh, so that if it's x, then the y coordinate is exactly the same. So 1.27 and then 4.09. Find the area of the region bounded by the graphs of G. So G is the dark black one. The inverse of G1, that's that. And the inverse of G2. I don't know. Oh, so that's for this part. Okay. So you want this area here, right? Now, I don't think that's double the what's bounded by the line y is equal to x. So, inverse of G1 and inverse. Remember, G1 and G2 are the same function, so the inverses are the same. One is just the positive and one is just the negative. What you can just do is the integral from the intersection point, which is, so this is a little bit weird because you've got 2 different functions. I'll just get rid of my drawings. So you've got a bit of g here, g2. This is kind of where they stop. Now, from this part here, so from this part where that you stop, all the way here, you've got the integral from of the G1, inverse of G1 minus G2. But then for the rest of it, you've just got G1 minus G of x. So, I'm not sure if if the CAS will find the inverse. Let's see. So menu 3(1), x is equal to g of y, comma y. No, it doesn't want to do that. So even approximated? No. So what you can do, maybe then it is double. Yeah, it is double. It has to be double because it's going to bisect. So what we can just do is the integral from this point here is, as we said, 1.27 all the way up to the next intersection point, 4.09 of the top, which is x minus g of x dx, and then multiply that by 2. And that should work out. I don't know if that's probably, I don't think it's any more work than that. So 1.27 is this one, and then the top one is 4.085, and it's going to be x minus g of x dx, and that is 5.56 units squared. All right. Let h be equal to 1. They just love transformations. Let h of x be equal to 1 on k times f of k minus x. So I think that's in the form that was talked about here. So this is 1 on 2, and then the 2 is there. So it's 1 on k. You can just kind of replace that with k. The turning point of h always lies on the graph of the function y is equal to 2x to the power of n, where n is an integer. Okay. Now the turning, okay, so if you just considered the case where k was equal to, the k is equal to 2, so this one here, your turning point was 2, 1. Now that lied on the graph, if you sub in, so y is equal to 2x to the power of n. Was it 2, 1? Yeah, it was 2, 1. And we can just sub in 2, 1 here. 1 is equal to 2x to the power of n. That doesn't make sense. Did I make a mistake? 2, 1. That was the coordinates, wasn't it? Or was it 1, 2? No, it's 2, 1. And that was in the same form as this here. So it should be the case for 2 okay, sorry. 2 times 2 to the power of n. So that means 1/2 is equal to 2 to the power of n. And that means n is equal to -1. Alright, 2 more parts, then done. Let h1 be equal to that. The rule for the inverse of h1 is equal to that. What is the smallest value of k such that h will intersect with the inverse of h1? Give your answer correct to 2 decimal places. So if a function intersects its inverse, that means h1 is equal to x, so it intersects the line y is equal to x, and h1 dash is intersect, so the gradients are the same. So that's like, if you think about it, if that's the last point that they intersect on the line x before they move away from each other, that means that at that point they intersect, so with the line y is equal to x, and also it has the same gradient as the line, their tangents. So you can probably solve that, and hopefully you can get k. Let me see. So if you just, going to define h of x again, and that is ln k over 2 times x plus 1/2 times the square root of k squared times x squared minus 4 plus k. And that's the plus k is on the outside of the log. Alright, so just making sure I've defined that correctly. Now, we just want to solve menu 371. We're solving for x and k. And first of all, h of x is equal to x. And second of all, the derivative of h of x is equal to 1. You can do a control enter. Oh, of course it didn't work. What we can do is a slider. But smallest value of k. No, I don't want to do a slider. So h of x is equal to x, and the derivative is equal to 1, and it still didn't want to work. Is that the same function as... okay, so if you look here, this is the same value, the same h, so this is still h. So if you just take the case where k is 2 like we did before, that's just going to be, it's going to be a much easier function, log base e of x plus 1/2 square root k squared x squared minus 4, which is, you can take out 2 and you're just going to have x squared minus 1, and that cancels the 1/2. Now that was this graph here. h1 is the inverse of this graph, so that's g1 inverse, and it's from 2 to infinity. So 2 to infinity, that was probably, which value? Is that g2 or g1? So that's going to be there probably. It was going to be starting at 1, okay, and going on to infinity. So that's probably going to be, and we want these to intersect on here. Sorry, just looking at this, we want this and this to have their intersection point here, right? Now, I might just use a slider because that's usually, okay, so we don't actually need the inverse. You can probably do it with, okay, so instead of using the inverse is too complicated. They've probably just tried to confuse you a bit, as always. So here, just define g of x as this, but with k instead. And then the same simultaneous equation. So menu 371, x and k. The first one, g of x is equal to x, and the second one, the derivative, so shift minus g of x is equal to 1. Just do control enter. And we get it's only given me negative, although it says k is between 0 to infinity. I think I'm just going to take the positive. Let me just check that. So if I just sketch g of x, I'll just open a graphing page and just sketch g of x. Yeah, we'll create a slider, and then we can also sketch, I'll do a relation, so menu graph entry relation, and just sketch x is equal to g of y. If we put k as, so negative 1.27 was there, and let's just try positive 1.27. Okay, so positive 1.27 is the answer. So let's write that down. It is possible for the graphs of h and h inverse to intersect twice. This occurs when k is equal to 5. Okay. Find the area of the region bounded by the graphs of h and the inverse of h when k is 5. Give your answers correct to 2 decimal places. So when k is 5, let's just take a look at what that looks like on the graph. Just going to change the definition to be 5, and tab g of x. Oh, so that's what it is. And what you can do to sketch the inverse is to do menu, graph entry, change it to a relation, and just do x is equal to g of y. And that's your thing. And if they intersect twice, as you can see, and you want this area. So if you just zoom in, it's actually not too bad, because if you find this point here, okay, it is a little bit bad, but you can imagine that you're just looking at the, let's draw the line y is equal to x. Oh, okay, well that helps. Now, if you just imagine that this is all the other way around, right? So this graph is the one that looks a bit like a parabola. And the one on top. So I guess what you can do is, you can easily find the I hope you can find the area just like this to get an answer mark at least. It doesn't even let me do relations. Oh, that's going to be tough. Let's try and find intersection points. Okay, so we've got an intersection there, and then we'll find the other intersection. I'll just get rid of this graph, it was kind of useless. So intersection, and starting there and finishing there. Okay, so we've got, I'll write down the intersection points: 1.451, 6.962, and 2.486, 2.486. Okay, so those are our two intersection points. Now we want the area, but just from here, it's just this graph here, which has two parts. It is the inverse of that, which is a log of a plus and minus square root. Now what you can do for that graph to get this area is just switch the x and y's and do the inverse of this minus the inverse of that. So I'll just go back to the iPad and draw it out. So what we had was this, and then something like that. Now I'm going to draw it on a different axis. What you can do is just imagine that you've taken this and inversed it, basically, so to look something like that. 1 and 6. Yeah. So initially this was the 2 2. No, that's the 1.451, 6.962, and this is the 2.486, 2.486. Now, when we flip it around to be an inverse, I think it's actually going the other way around. So it's looking a bit like, actually, yes, it is. So what's happening is it looks more like this with the inverse. And it's going to be this is the 2.486. And this is the 6.962.1.451. So you can do the area with inverses, and you don't have to use these horrible functions. I'll just move that out of the way. It's going to be the integral of this. Now, I'll just talk about, I wasn't even showing the screen. So I've just did this and made it like inverses. So now it looks like that. And now I've just drawn it out the other way. So because here we don't really know how to find this function, and the function is just going to be ridiculous. So here now it's just the top function minus the bottom one. I just need to figure out what are the equation of the inverses of each one. So this one here is graph f1, which is, I'll go back to my function entry, menu, graph entry, function, and you can see f1 was g of x. And they told you the derivative of g of x. They told you the derivative of, the inverse, sorry, not the derivative, of g of x, which is this one, just when, now we're talking about when k is 5. So it's going to be the integral from 2.486 to 6.962 of, you can say h1 of x, which is this, or the inverse, so h1 inverse, and that is the log base e of 5 over 2. That's fine, we won't write it all out. And then minus this function, and that function was, what was it? It was the inverse of, so now that graph is just your exponential. So now that's just g of x, like when x is 5. So just h of x, I think, I hope. So if you were to work that one out, you're going to, so I've just drawn it here, that's my expression. And this, we found that that was going to be the h inverse when k is 5, and that's going to be just your exponential. So let's go to the graphing page and say shift plus 2.486 all the way up to 6.962. Now I don't remember, oh, I did write up the function somewhere up here. I did here, here. So it was that function, that's the inverse. So I'll copy that and go all the way down. And I'm just going to change k to be 5, right? So that's 5 squared and then 5. And then that is going to be minus g of x. But g of x, remember, yeah, I did do it when it's 5. So g of x dx, and hopefully this works. 32.49 is to 2 decimal places. So that's my answer. I might be wrong. I don't know. It's pretty tough. This exam is quite tough. It's long. It is doable, but I think there are a lot of marks where you just don't want to waste your time. So just finish all the easy marks that you can get. Like question 1, I think was pretty easy, which was just like Newton's method. And, oh no, that was 3, but there was still like quite some easy marks to get marks. Don't waste your time on the hard marks, like multiple choice questions. The last question was worth 2 marks. But just, I hope everyone did well, and good luck for the rest of your exams.